Faults within the intake, combustion or exhaust system can cause fuel trim codes to be set. When diagnosing these faults, it's a good idea to understand the system before commencing any work. The Engine Control Module, or ECM, controls a closed-loop air-fuel metering system in order to provide the best possible combination of drivability, fuel economy and emission control. The ECM monitors the heated oxygen sensor signals and fine-tunes the fuel delivery based on this signal once the engine has entered closed loop. Any change made to the fuel delivery system affects the long and short-term fuel trim values. The short-term fuel trim values change rapidly in response to the oxygen sensor signal voltages. This video will cover P0171 System 2 Lean Bank 1 and P0174 System 2 Lean Bank 2. On this vehicle, the code or codes will only be set once the vehicle has completed the drive cycle applicable to the DTC and the fault has occurred for longer than the programmed period of time. With a scan tool connected and the ignition on, observe the manifold absolute pressure value and compare to an altitude versus pressure table. Check the long-term fuel trims. For this code to set, the ECM would indicate that excessively high long-term trims have been measured. If available, check for any misfire data. This may help to isolate a fault to a cylinder. This code has been set because the ECM has determined that the system is running too lean. This could be caused by problems in the fuel, intake, or exhaust systems. Confirm the fuel level is sufficient before continuing with diagnosis. Inspect the intake ducting for any cracks or distortion. A collapsed intake pipe will cause an air restriction. Remove and inspect the air filter. A dirty or restricted air filter is a common cause for a poor running engine. Some oiled type air filters may also cause problems. Using a leak detector, check for any smoke escaping the intake system. Be sure to inspect the brake booster closely. Any unmetered air entering the system will cause a lean running condition. Inspect the EVAP or evaporative emission system for any damage or leaks. Check that the positive crankcase ventilation system is operating correctly. Ensure that the engine oil dipstick and oil filler cap are secured and sealing. A sticking or damaged PCV valve may also cause an engine to run lean. A sticking or leaking EGR valve could also be a reason for lean running. If available, use a scan tool to actuate it while listening to the engine. A correctly operating EGR will cause an idling engine to run roughly when activated. If this does not occur, remove the EGR pintle and inspect for carbon buildup. Depressurise the low pressure fuel system by removing the fuel cap, the fuel pump fuse or relay and running the engine until it stops. Connect a low pressure fuel gauge and re-enable the fuel system. Confirm the pressure and flow is correct to the vehicle specifications. Take a sample of the fuel and check for ethanol and other contaminants. If the vehicle has gasoline direct injection, the system may log high pressure fault codes as well as fuel trim fault codes. Diagnose and repair any high pressure DTCs first. Let's raise the vehicle and inspect the exhaust system. A visual inspection will reveal any major damage or missing componentry. Some aftermarket or larger than specified systems may cause these fault codes. Any leak before the upstream oxygen sensor will cause these DTCs. This can be checked by using a leak detector. It's highly unlikely that an oxygen sensor will cause these fault codes without the presence of dedicated oxygen sensor DTCs. Always diagnose oxygen sensor codes before fuel trim codes. It may be necessary to remove the intake manifold to access the fuel injectors. Take this opportunity to inspect for leaks or gasket damage. To inspect the fuel injectors for any blockage, dribble or poor spray pattern, they'll need to be removed and bench tested. Cleaning or replacement may be required. Now that we have checked and confirmed all of our external fittings, we need to take a closer look at the engine and its major components. Perform a cylinder compression test to confirm the mechanical integrity of the engine. Compression values should be within specification for the vehicle. Fuel trim values should be the same on both banks of a V-configured engine. A fault in a shared system will cause both bank trim values to be altered. An excessive value on one bank will indicate a problem on that side. Once all faults have been found and corrected, perform a fuel trim reset with a scan tool and clear fault codes. Perform the appropriate drive cycle for the DTC and retest the system. Confirm that the fuel trim values are now within the manufacturer's specifications. And that's how we diagnose fuel system 2 lean fault codes. Remember that these fault codes can be set by intake, combustion, or exhaust problems. Understanding the system operation will ensure that you diagnose correctly, saving both time and money. Thanks for watching. See you next time.